we are asked to determine how many elements belong to at least one set. All right, so look, here's how we're going to handle this. We've got set A, set B, set C. So how can they belong to at least one set? Well, I think what they could do is they could belong to, let's see what we can get here. They could belong to exactly one or exactly two or exactly three. Does that make sense? I mean, what we want here is at least one. So how do you get at least one? You got three things here. You got A, B, and C. You've got three things. And at least one is going to mean one of them, or two of them, or three of them. So let's count exactly ones. Then we'll get exactly twos and exactly threes. So how many ways can we get exactly one? Well, how about this region right out here? There's 4 in that. That's only in A. And then there's 7 that's only in B. And there's 3 that's only in C. So exactly 1, I think what we're looking at is this. 4 plus 7 plus 3. That's in exactly 1. Here's only A, only B, and only C. And then there's exactly 2. So how many ways can we get exactly 2? So let's look over here. What about this right here? You see that number 2? That region right there, everything in here is in exactly 2, right? It's in A and B and nothing else, just only A and B. What about this 8? Well, these 8 elements are in B and C. They're not in A. Just these 8 are in B and C. So anything in here, they're in exactly 2. And this element out here is in exactly 2 of them, right? It's in A and C. So I'm looking at this. I'm looking at 2 plus 8 plus 1, right? It's the 2 plus the 8 plus the 1. Those are the number of elements that are in exactly 2 sets. And then finally, exactly 3, well, that's going to be this 6 elements right here, right? Anything in here is in all 3 of those. So that's just going to be a 6. So let's add these up. This is going to be a 14. This is an 11. That's just 6, so we're going to get, I think when we add those, we get 31.